Assalamualaikum warahmatullahi wabarakatuh and a very good day. So today in this video we will discuss about how to sketch spheres in three-dimensional coordinate system. As mentioned in the previous lecture, basically you need to know what is the standard equation to represent surfaces in three-dimensional coordinate system. Right now, we would like to discuss about spheres. So basically, this is the equations. So let me write the title first. So this is the equation that represent a sphere centered at the origin. It is given as x squared plus y squared plus z squared is equal to r squared. R here represent the radius of the sphere. If you look carefully in your module by right for figure 1.6, the graph explain about a sphere where the center is no longer at the origin. Instead, the center is at some point HKL, and this is the equation to represent sphere center at the origin and r is the radius. So if sphere has center at point C consists of coordinate H, K, L. So the equation is given as x minus H squared plus y minus K squared plus z minus L squared is equal to r squared. So this is the standard form of an equation that represent a sphere centered at point HKL and having r as the radius. So let's take a look on the example that relates with sphere. So basically, you need to have 3 steps to sketch a sphere. As mentioned in the lecture, the same procedures that we have used to sketch a paraboloid will be applied when we try to sketch a sphere. Step number 1, where you will let z is equal to 0, because you would like to observe your surface from z direction. This surface from 3-dimensional coordinate system will be mapped onto xy plane in 2-dimensional coordinate system. Let's say we have this equation, x squared plus y squared plus z squared is equal to 4. By letting z as equal to 0, you will get x squared plus y squared is equal to 4. So this equation, when you try to illustrate in 2-dimensional coordinate system that involve y and x axis, eventually you will end up with a circle center at the origin and having radius r is equal to 2. So let's move to step number 2. Step number 2, you have to observe your surface from y direction. So you have to let y is equal to 0, then you will get x squared plus z squared is equal to 4. Again, when you try to illustrate in 2-dimensional coordinate system that involve z and x axis, you will see that you will end up having again a circle with radius r is equal to 2. So let's move to the last step, which is you try to observe your surface from 3D at x direction. So you will let x is equal to 0, and your surface from 3D will be mapped onto zy plane. Therefore, when you try to get the equation, you will get y squared plus z squared is equal to 4. Again, when you try to illustrate in 2D that involve z and y axis, you will end up with a circle having the same radius r is equal to 2. So what should I do right after this? I have to combine everything that I have obtained from step 1 until step 3 so that I can sketch a surface in 3-dimensional coordinate system. Okay. Okay, you can see clearly by combining whatever we have from step 1 until step 3, it will help us to see clearly when we try to illustrate in 3-dimensional coordinate system. Before we try to solve a problem related to spheres, let us discuss about hemispheres. So, if you look carefully in the module, we have discussed a little bit about hemisphere. Before this is the standard form of equation that represent a sphere. And then let us try to let r is equal to some constant. Then I'll get x squared plus y squared plus z squared is equal to 4. What should I do if I try to get equations to represent hemispheres? So, by letting one of the variable as the subject of your equation, for example, let z to be the subject of your equation, you get z squared is equal to 4 minus x squared minus y squared. And then you try to get rid of the squared from the left hand side, you will get z is equal to plus minus 4 minus x squared minus y squared. Okay, here we have two equations right after we get rid of the squared notation on the left hand side to the right hand side. So let's try to observe whatever you have on your module on page 39. If you look carefully on page 39, so by letting z as the subject of your equation, you will be able to get two hemispheres, upper hemispheres and lower hemispheres. So let me illustrate the hemisphere for you. Okay, let me do something so that I can get the axis easily later. So this is the hemisphere. When you let z as the subject of your equation, you will get two hemispheres, upper hemispheres, which can be represented as positive z 4 minus x squared minus y squared. Meanwhile, Okay, so you will end up with this lower hemisphere, and this lower hemisphere can be represented as z is equal to negative 4 minus x squared minus y squared. So basically, the same procedures will be applied when you try to let y as the subject of your equation and by letting x as the subject of your equation. Please look at the module on page 39. So these are the right and left hemispheres when you let y as the subject of your equations. If you look at page 40, you will see that these two hemispheres look exactly like these hemispheres on page 39. But for your information, there are two different hemispheres, two different hemispheres, since if you look carefully at the way the author represent the axis, because it will be quite difficult if you use the standard representation of axis to illustrate the hemispheres where x is the subject of the equations. Hence explain why the authors need to readjust the position of axis. Even though they look similar, but they are two types of different hemispheres. So I really hope you can relate with the explanation in the future. So right now, why don't we try and focus on solving the next example? So we will try to look at example 1.3.4.1. So you have been given with this equation x squared plus y squared plus z squared plus 4x minus 6y plus 2z plus 6 is equal to 0. And then it is written in its general form. So the question asks you to show that this equation will give you standard form of equation that represent a sphere. Hence, the author also asks you to determine its center and radius. So the only way to solve this problem is by completing the square. So you have to recall back how to perform completing the square, since this general equation involving three different variables. So based on what we understood about completing the square, so you have to perform completing the square 3 times. So in this case, my idea would be you have to rearrange x with x, variable y with y, and variable z with z. So I'll get x squared plus 4x plus y squared minus 6y plus z squared plus 2z plus 6 is equal to 0. Right after that, I will try to completing the square according to the variable. So I will focus on x first. I will get x squared plus 4x plus 4 divided by 2 minus 4 divided by 2 squared. So I have done with variable x, and then I'll focus on variable y. I'll get y squared minus 6y plus negative 6 over 2 squared minus 6 over 2 squared. And then right after that, I will focus on completing the square variable z, I will get z squared plus 2z plus 2 divided by 2 squared minus 2 over 2 squared plus, don't forget, 6 equal to 0. By using the completing the square technique, I will get x plus 2 squared minus 4 plus y minus 3 squared minus 9 plus z plus 1 squared minus 1 plus 6 equal to 0. My final answer will be x plus 2 squared plus y minus 3 squared plus z plus 1 squared. Negative 4 minus 9, negative 13, negative 13, negative 1, negative 14, negative 14 plus 6, negative 8 equal to 0. Then I will rewrite my final answer. I'll get x plus 2 squared plus y minus 3 squared plus z plus 1 squared equal to 8. So this is actually equation that represent a sphere where the center of the sphere is equal to negative 2, 3 and negative 1. Meanwhile, radius r is 8. So in order to solve this type of problem, you need to know how to completing the square. I really suggest you to go and look for books related to calculus to recall back what you have learned about completing the square, or you can simply hit and go to Google and look for completing the square of variables. And I really hope you are able to redo the example listed on page 41. So let's take a look at the next example. Example 1.3.4.3. So basically, this equation or these problems on example 1.3.4.3 eventually ask you to generalize or to come up with answer given by that equation. So for question A, obviously A is sphere, center at origin and with radius 2. Okay, let's take a look at question B. Question B, again, you will get a sphere center. By right, without the condition z larger than or equal to 0, you will end up with a sphere with radius 4. But since there is a limitation in terms of z should be always larger than or equal to 0, hence that equation will produce a upper hemisphere. For question C, obviously, since y is the subject of your equation, you will end up with a hemisphere with radius 1. So I really hope you can go through the example on your own, and then please take a look at few examples that you can go to in this example. So let's take a look at the next topic, which is ellipsoid. If a sphere in our daily life, we can relate with a ball, an ellipsoid normally can be related with a rugby ball. So somehow the standard equation that represent ellipsoid will be somehow similar with equation that represent a sphere. This is the standard equation that represents an ellipsoid. So if you understand the equation that I have been writing earlier, by right, the difference between this equation with equation that represents spheres, for sphere the radius are same throughout axis. For ellipsoids, if they have different radius across the axis, so you can see that it will produce an ellipsoid. So let's take a look at question A. For this example 1.3.5.1. So for this example, you are given with this equation: 4x squared plus y squared plus 4z squared is equal to 16. If you look at the equation carefully, you will see that throughout the variables they don't share the same coefficient, so you cannot deduce it as equation that will produce sphere. So in this case, when you come across with this type of problem, what you can do is that you have to make sure whatever you have on the right hand side is equal to 1. So for this question, in order to deduce 16 to 1, so you have to divide the whole equation with 16, then you will end up having x squared over 4 divided by 16, 4 plus y squared over 16 plus z squared over 4 equal to 1. So this equation indeed will give you an ellipsoid, and the radius at x and z axis is actually 2. Meanwhile, at y axis it will give you 4. Therefore, let me sketch the axis first. So I will end up having an ellipsoid. So in this case, it will be measure about y axis. So you will end up with this type of shape. So you can go through the examples for B and C. By right, you should be able to get the same answers as listed on page 43. I believe I have come to the end of this topic 1.3, which is right now we will learn on how to sketch a cone. So when you try to solve problem related to topic 1.3, as mentioned earlier, you don't have to go through all the steps. So as long as you know that this equation will provide this type of surface, you can straight away sketch the surface. So in this case, let me discuss with you the basic equation that will produce a cone or cones. So this is standard equation that represent cones. So you can always play around with this equation to get an idea on how cones are developed. So in this question, what should I do? We have to go through all the steps, step 1, step 2, step 3, so that we get the idea how it end up with figure on example 1.3.6.1 on page 44. So let's straight away go to example 1.3.6.1. So for example, right now for step number 1, so step number 1, as mentioned earlier, you can choose to let z is equal to 0 or draw the level curve. So according to this question, it will be inappropriate to choose z is equal to 0. What should we do for step number 1? We sketch the level curve. So z will be constant k, and constant k can take any value. For this example, I'll choose 1, 2, 3. So let's solve for each k. Let k is equal to 1, x squared plus y squared is equal to 1. K is equal to 2, x squared plus y squared is equal to 4. K is equal to 3, x squared plus y squared is equal to 9. So when you have to illustrate this level curve on xy plane. So you will end up having families of circle. So when you look at this surface from z direction, you end up having families of circle. So let us proceed with step number 2. Step number 2, you have to let y equal to 0. For this case, z squared is equal to x squared and z is equal to x. According to what we have learned from topic 1.1, you have to sketch these two axes, z versus x, and then you will end up having a straight line. So move to step number 3. For step number 3, you have to let x equal to 0. By letting x equal to 0, you get z squared is equal to y squared. Z squared is equal to y squared. When you try to simplify, you get z is equal to y. So again, I'll sketch two axes, z versus y, and then I'll end up with a straight line. By combining all curve you have obtained from step number 1 until step number 3, you end up having a cone. So let me highlight the cone first. Okay, you can predict what will happen if you let x or y on the left hand side. Okay, what will happen if I have y squared equal to x squared plus z squared? Okay, I believe each and every one of you can predict what will happen to this curve or to this surface. So it will be traced along y-axis. Okay, by letting x on the left hand side, you will get x squared equal to y squared plus z squared. Okay, I really hope you can relate up to this point. Okay, so it will be traced along x-axis. So let's move back to the first example that illustrate a cone. So basically, z squared is equal to x squared plus y squared. By eliminating squared notation on the left hand side, you get z is equal to plus minus z x squared plus y squared. So the best equation to represent the upper part of the cone is actually z is equal to positive x squared z x squared plus y squared. Hence, this one can be represented by z is equal to negative z x squared plus y squared. Let's move to this example over here, or my own example. So this is actually y is equal to z positive x squared plus z squared. Meanwhile, the left part of the cone is actually can be represented by y is equal to negative z x squared plus z squared. So I really hope you can guess what will happen to these two cones. So in this case, this part can be represented by x equal to positive z y squared plus z squared. Meanwhile, this part of the cone can be represented by x equal to negative z y squared plus z squared. Okay. Okay, so let's play around with the question. Since I have explained everything related to basic equation that represent cone, so let me give you this question. Sketch y is equal to 4 minus z x squared plus z squared. So when you have this type of equation, so you have to try to answer it calmly. So right now, don't forget to sketch the three-dimensional coordinate system. Okay, I'll show you the transition from one to another. So basically, when you have this type of question, please be clear with the subject of your equation. So right now, the subject of your equation is y. Therefore, your curve will lies mostly at y-axis. So in this case, this is when y is equal to positive z x squared plus z squared. So when you look at this equation, you have negative, am I right? So right now, the negative part of this cone can be illustrated as this one, which is y is equal to negative z x squared plus z squared. But the question asks us to sketch y is equal to 4 minus z x squared plus z squared. So right now, you sketch another axis of three-dimensional coordinate system. So the cone should be moving 4 units to the right, since you have positive 4. So right now you have to locate where y is equal to 4 first. Y is equal to 4 is somewhere over here. Therefore, you will get this cone. So this is actually y is equal to 4 minus z x squared plus z squared. So when you try to answer question related to topic 1.3, so you have to be clear with the instruction given in the question. So you have to decide how to solve the problem. So let us discuss another problem related to a cone. Let's say I give you this question. Sketch x is equal to -7 z y squared plus 3 or 3 z squared. So when you have this question, please ignore whatever coefficient that appear right in front of each variable, because it won't affect the way you sketch your surface. So right now, when you have this type of question, what you can do is that you have to be clear with the equation given to you, whether it will produce parabola, sphere, hemispheres, cylinders, plane, or ellipsoid or cone. So in this case, since we are in this subtopic related to cone, so this equation will produce a cone. Whenever you see the third notation appear in the equation, so you can always relate with hemispheres or cone. So in this case, this equation will produce a cone, and this cone will be traced along x-axis, since x is the subject of your equation. So right now, sketch the axis. So I will show you the transition. So this will be, okay, let me settle this one first. Okay, one more. Okay, so right now, if x is the subject of your equation, so this is the positive. So when x is equal to positive z, okay, this one is when x is equal to positive z y squared plus 3 z squared. So if you see that there is negative appear before z notation, you can always assume that it should be the other way around. So in this case, this is when you will end up with this cone when you have x is equal to negative z y squared plus 3z squared. And then if you look carefully to the question or the equation, you will see that you need to locate where -7, and this -7 will be along variable x, since x is the subject of the equation. So based on your understanding, this is where your -7, so it will be moving 7 unit at x-axis negative. So I'll use other color. So this is how you find x is equal to -7 z y squared plus 3z squared. So maybe you want to try another example. So let's go to the next example, where you have z is equal to 5 plus 2x squared plus 3y squared. So in this case, since z is the subject of your equation, by right, it will be traced along variable z. So I'll show the transition again. So let's try to answer this question together. Okay, So maybe in this question, 2 axes should be enough. 2 coordinate system is enough to show the transition. So I will get, so this is where the interesting part starts. So in this case, sketch the cone first. So ignore positive 5. So where is positive third? 2x squared plus 3y squared. So it should be traced along variable z. So you will get this one. This is z is equal to 2x squared plus 3y squared set 2x squared plus 3y squared. And then it needs to move 5 unit along z axis positive. So you locate where 5 first. This is where z is equal to 5. So you will end up having this cone elevate 5 units at z axis positive. So there you go. This is the cone based on the equation given to you, such as so this is the cone. So I really hope you get something from this video, and I hope you can spend some time to go through all the exercises on page 45, exercises 1.3, so that you can get yourself familiar with this question. And remember, this is one of the famous question that will be asked during mid-semester tests, which will be happen on March 2020. So till then, see you again in our class. Bye.